Good morning everyone. My name is Dhanashri Uphade. Today I will be presenting on the topic of food irradiation, enhancing safety and shelf life. This technology has the potential to revolutionize food preservation by ensuring safety and extending the shelf life of various food products. Then coming to the next slide, content of presentation. First one is introduction, then purpose of irradiation, source of radiation, radiation process, radiation dose and dose rate, effect on microorganism, effect on food, effect on packaging, advantages, disadvantages, comparative analysis and conclusion. The next is introduction. To begin with food irradiation is preservation method that uses ionizing radiation to effectively reduce or eliminate harmful microorganism or pest in the food. This technology is often referred as cold sterilization because it doesn't significantly raise the food's temperature, which helps in maintaining its nutritional and sensory qualities. By applying this process, we can eliminate harmful microorganisms or bacteria, which significantly lower the risk of foodborne illness. For example, we eliminate salmonella from food, uh, which reduce the risk of salmonellosis. Why with food irradiation extend the shelf life in a wide range of food products. Irradiation is a safe, reliable, and efficient tool that holds great promise for the future food safety. Then next is purpose of irradiation. There are various purposes of irradiation, which are food infestation, sprout inhibition, the extend shelf life, and reduce waste. First is food infestation. This technology effectively eliminate insect in stored food, which is crucial for maintaining quality during transportation and storage. Then second is sprout inhibition. Irradiation prevents sprouting in foods like potatoes, which can compromise their quality. By inhibiting sprouting, we can extend the shelf life of this product. Then third one is extending shelf life. By slowing down the spoilage process, food irradiation help maintain the freshness of perishable products for longer time. Then fourth is a waste reduction, which includes reduce the food waste by keeping food fresh and safe for longer time. In the world where food waste is a growing concern, this is powerful tool to reduce the food waste. Then next one is the source of radiation. There are three main sources of radiation: gamma rays, electron beam and x-rays. First one is gamma rays. Gamma rays is generally emitted from source like cobalt 60 or cesium 137. Gamma rays have a great penetrating power and making them more effective in treating bulk amount of food products. Then second is electron beams. Electron beams are generally reflecting high energy stream of electron of a target substance into food, and which are effective in killing bacteria and insect quickly. Then third one is the X-rays. X-rays are generally produced by reflecting high energy electron of a target substance, and this method allows for deep penetration, making it ideal for treating packaged food also. Each source has its own specific application based on their types of food or desired outcomes. Then coming to the next slide, uh, that is irradiation process. Irradiation process is highly controlled to ensure both safety and quality of the food. Firstly, we load the food on the conveyor system and pass the food into irradiation room where it is exposed in a precise amount of radiation. Doses absorbed by the food measured in kilograms is carefully monitored to achieve the desired effect, whether it's insect control, pathogen reduction, or sterilization. After the irradiation, food is unloaded and is ready for packaging or further processing. This process helps to maintain safety and quality of food without the use of chemical or high heat. Then next is a radiation dose. Radiation dose is a quantity of energy absorbed during exposure, and the unit of radiation dose is kilogram. There are three types of radiation dose on the basis of their quantity. First one is radicidation, second is radarization, and third is radapatization. First is radiccidation, is also known as low dose, that is it generally measure in less than 1 kilogram. These doses are generally used to control insects and prevent the sprouting in foods like fresh produce and tubers. Then second one is radarization. Radarization is also known as medium doses, and which is typically 1 to 10 kilogram. These doses are used to control pathogens like Salmonella and E. coli, particularly in meat and poultry. Then third one is radapatization, known as high doses, that is greater than 10 kilogram. And this level is used for sterilization, such as spices and herbs, and ensure the complete elimination of microorganisms, and this is precise to ensure the safety is achieved without significantly altering the quality of the food. Then next, radarization. Radarization is low dose process, typically under 1 kilogram, and which is particularly effective for insect disinfestation, sprout inhibition, and delay ripening. First is insect disinfestation. Uh, this treatment target insect in foods like grains, fruits, and vegetables, and which prevent damage and post-harvest losses in fruits, vegetables, and grains. Then second one is sprout inhibition. This radarization is generally used in potatoes for inhibit the sprouting and increase their shelf life and appearance of the food. Then third is ripening, delay ripening. In fruits and vegetable, radarization helps to slow down the ripening process and allow them to remain fresh and store or transport for longer period of time. The example of radarization is potato, lettuce, spinach, and chicken. Radarization is valuable method for extending the shelf life of fresh produce without compromising its quality. Then next, second one is radicidation, which is low dose process, which is medium dose process, typically between 1 to 10 kilograms. Radicidation involve radiation between 1 to 10 kilograms and used to control pathogens, uh, which is generally used to control pathogens and insects and delay mold growth in strawberries and other fruits. Uh, First one is pathogen control. Radicidation is effective for targeting microorganism or bacteria such as Salmonella and E. coli, particularly in meat, poultry, and seafoods, and making this food is safer for consumption. And it is also used in delay mold growth in strawberries and other fruits, and reduce the chances of spoilage of strawberries. And it also control salmonella, shigella, and E. coli, and also campylobacter, which causes foodborne illness and extend the shelf life of various products. Then next is radapatization, which is known as sterilization, and the range of dose is greater than 10 kilograms, which include sterilization of food, killing microorganism and insect in spices. First is complete sterilization. This method completely eliminate all microorganisms including bacteria, spores, and ensure the food is completely safe and shelf stable for a longer period of time without refrigeration. Then example of red appetization is spices, herbs, which generally often carry microorganisms. This process sterilize them without affecting their flavors and aroma. And it is generally used for ready to eat meals, uh, especially military and space missions where long term of storage is required. Then next is benefits of irradiation, which includes pathogen elimination, reduce risk, delay ripening, and regulatory oversight. First is pathogen elimination. Pathogen elimination is effective to eliminate harmful microorganisms, significantly reducing the risk of foodborne illness. Second one is reduce contamination. Irradiated food are less likely to harbor harmful bacteria and making them safe throughout the supply chain. And its delay ripening process, which generally slow down the ripening process in fruits and vegetable and extend their shelf life and keep fruits and vegetables fresh for longer period of time. Then next is if radiation effect on microorganism. In that it reduces the pathogen like E. coli, salmonella, which is generally carried out by rupturing or disturbing the DNA molecule of a microorganism. When DNA is damaged, the microorganism lose their ability to function and reproduce, which leading to death or inactivation. And this mechanism is generally used to kill the microorganism in food products. There are various microorganisms like bacteria, viruses, parasites, fungi, and molds, which is generally killed by radiation. First is bacteria. Irradiation is highly effective against bacteria, particularly pathogens like E. coli, salmonella, and listeria. The energy from ionizing radiation break their DNA and making replication impossible, and which reduce the risk of foodborne illness. Depending on the dosage, it can either eliminate bacteria entirely or reduce them to safe level. Then second is viruses. Viruses is more resistant than bacteria. Viruses can still be inactivated by irradiation at higher doses. This is crucial in controlling foodborne viruses like hepatitis A and norovirus, which cause severe gastrointestinal illness. And third is parasite is equally effective at eliminate irradiation is equally effective for eliminating the parasite from foods such as uh, toxoplasma in meat, which can causes serious infection in humans. This ensures this parasite is completely destroyed and safeguarding for food safety. Then next is fungi and molds. Uh, Irradiation is generally inhibit the growth of fungi and molds, which is responsible for food spoilage. By preventing the germination and extend the shelf life of products like fruits and vegetables and grains. Then next is effect on packaging. When it comes to packaging, ensuring compatibility with irradiation process is the key for uh, irradiation. Since irradiation can penetrate through packaging, it minimizes the risk of post-processing contamination. Not only does this improve food safety, but it also facilitates easier handling without compromising package integrity. Mainly organic packaging material is particularly well suited for irradiation process, and that ensure the packaging remain intact while maintain the freshness and quality of food inside. Then next is effect on food. Irradiation shows various beneficial as well as adverse effect on food, which include at a commercial dose level, irradiation has minimal effect on the food, that is digestibility of protein and preserve most nutrients. When dose dose rate is high, it can degrade some vitamins like riboflavins, niacin, and vitamin D. Similarly, amino acids in protein may undergo changes that affects the aroma and taste of a food. And mm, and that said, at a lower dose, irradiation maintain the overall quality of food. For fruits and vegetable, it preserves freshness by controlling pest and delay ripening, while in spices retain their flavor with enhancing the microbial safety. In meats and poultry, and irradiation significantly reduce pathogens and ensuring the food is safe for consumption. Then next is applications. Irradiation shows application in various sectors like fruits and vegetable, meat and poultry, spices and herbs, and grains and cereals. First is fruits and vegetable. Low dose irradiation is generally useful for fruits and vegetable, which shows a delay ripening process and control insect infestation, and prevent the sproutings in tubers like potatoes, and maintain the quality of fruits and vegetable during storage and transportation. Then second is meat and poultry. Meat and poultry generally required medium doses to reduce the harmful pathogens like Salmonella, E. coli, Campylobacter, and by using the medium doses, meat and poultry product make safer and preserve the nutritional value of these products. And third is herbs and spices. Herbs and spices required higher doses to sterilize the products and completely remove the microorganism from this product without compromising the flavor and aroma of spices and herbs, and increase their shelf life during storage. Then fourth one is grains and cereals. Irradiation prevents insect infestation and preserve the quality of these products during storage. So we maintain the nutritional value and extend the shelf life of grains and cereal for a longer period of time. That is from above, the irradiation enhance safety, extend freshness, and ensure the food retain its quality for longer period of time. Then coming to the next slide. This slide shows irradiated spices. Irradiated spices generally, which includes green cardamom, black cardamom, cloves, and ginger. Then next slide includes irradiated fruits and vegetable, which includes fruits like strawberry and vegetables like carrot, spinach, and various other vegetables shown in images, which are generally uh, extend their shelf life with using irradiation process. Then coming to the next slide, we which include irradiated meat and poultry. There we made these images shows various irradiated products, generally include meat, eggs, and various poultry products also. Then moving to the next slide, which shows pros and cons of irradiation process. Uh, Pros are, are pathogen elimination, extend shelf life, it is cold process, then chemical free preservation process, and wide range of applications. The first one is pathogen elimination. It is highly effective technology to eliminate harmful bacteria and viruses, which reduce the risk of food illness which reduce the risk of food illness. And the second is extending the shelf life of a product, which generally useful for fruits and vegetable and grains also, and which is used to reduce the food waste. Then third is cold process. uh, Irradiation process does not require any type of heat to to extend the shelf life of a product. It is cold process, it also known as cold sterilization. Then fourth is cold chemical free preservation. It doesn't require any chemical preservative, and uh, for making a product safe. Then it is automated process. Then cons of irradiation: nutrient loss, high capital cost, potential resistance, and consumer acceptance. First one is it require high capital cost for setting up of irradiation facilities is expensive due to specialized equipment required for the process of irradiation. Then second is nutrient loss. At higher dose level, some vitamins like vitamin C and niacin are degraded, and they shows impact on minimal standard doses. Then third is potential resistance. There are concern in microorganism might develop a resistance over time, although this is still under study. Then fourth is consumer acceptance. Due to public perception remain challenge for misconception about irradiated of food safety of products. Then next is this slide shows comparative analysis of food irradiation in relation with freezing and drying preservation method. Uh, then first is irradiation is uses ionizing radiation to eliminate pathogen and extend the shelf life with minimal impact on nutrition. It preserves texture and flavors since it's a cold process, but comes to comes with high setup cost and consumer acceptance. Then freezing is generally used to use and preserve most nutrient by slowing down the temperature and slowing down the spoilage. However, it doesn't eliminate bacteria and can change texture post thawing. And the ongoing cost of a cold storage is also high. And next is drying remove moisture and inhibit the bacterial growth and extend the shelf life at lower cost. but significantly reduce heat sensitive nutrients like vitamin A and vitamin C, and it also alter the texture and taste of the product. uh, from above comparison, irradiation has minimal nutrient loss at low doses and eliminate pathogens, and freezing preserve most nutrients but doesn't eliminate bacteria. And drying is cost effective, but it causes nutrient degradation. Each method has its strength and limitations, and the choice depend on the type of food and desired shelf life and the cost required uh, to proceed these processes. Then next is conclusion. Food irradiation is cutting edge technology that addresses many challenges in food preservation and safety. It effectively eliminates harmful microorganisms, control pest, and reduce foodborne illness risk, while extend the shelf life of product. Despite the challenges such as high capital cost, consumer perception, and irradiation shows unique advantages, that is preserving quality without the use of heat or any chemical. Then the as the research continues and awareness grows, we will see even broader application of this technology. It's a promising solution to food safety and sustainability of challenges in today's world. Thank you.